Okay, so first thing first, don't forget to write your name, date, and period on the top left of the paper. And today, we will be working on Lesson 1-5 Conditional Statements. Now for the objectives. So first things first, we will write conditional and biconditional statements. And we will also find the contrapositive, the converse, and inverse of a conditional statement. We will also find the truth values for conditional statements and complete truth tables. Now on to the definitions. A conditional is an if-then statement that relates a hypothesis, the part that follows if, to a conclusion, the part that follows then. Conditionals can be represented as P arrow Q, and it can be read as if P, then Q, where P represents the hypothesis and Q represents the conclusion. Now we're going to do a conditional. We will be doing and now we'll be writing a conditional statement. Write each statement as conditionals. So for example A, we have here our statement. A triangle with all angles congruent is equilateral. Here we have our P. Then we have our Q. So we will be taking P and write that in our blank space. If a triangle with all angles congruent then it is equilateral. So I hope that you can see from this example, we have our P, which is if a triangle with all angles are congruent, then it is Q, which is it is equilateral. There you go. And now we'll practice some more with our example B. Our statement states, Alberto can go to the movies if he washes the car. And just a little hint, we have our keyword if. So it's not as direct as example A, but we can see that with the keyword if on the middle of the statement, we can say that this is P and this is Q. So when we write the conditional, we would say if Alberta washes the car, because that's our P, then Q, which is he can go to the movies. So as you can see, that was our conditional statement. If Alberta, P, it washes the car, then Q, he can go to the movies. So now we will be going over the different types of conditional statements. We have here our original definition, which states that a conditional has a hypothesis and a conclusion. our symbol for that was P arrow Q, and we read it as if P, then Q. Our second definition is the inverse. And this means that it reverses the hypothesis and the conclusion of a conditional. So we would take the original conditional statement, if P then Q, and basically they would switch places. So then the symbol for this is that Q starts first, then P. So if Q, then P. And now the third definition, which is the negation. The negation of a statement has the opposite meaning of the original statement. And we can put the symbol for this as a squiggly line or a sideways S. And we read this as not P. And we could also do not Q. And now the fourth definition, which is a converse. And this is obtained by negating both the hypothesis and the conclusion of a conditional. So we would take the original statement, the original conditional, and negate both of P and Q. So if P, then Q. And we read this as if not P, then not Q. And now our last definition, which is the contrapositive. And this is obtained by negating and reversing both the hypothesis and the conclusion of a conditional. And the simple way to do that is if you would take the converse symbol and you would switch, kind of like the inverse. So we have here not Q, then not P. And we read this as if not Q, then not P. Okay, and now we will be writing and evaluating the truth value of a converse. So we will take this example A, and the statement of that states, if a polygon is a quadrilateral, then it has 4 sides. Here we have our keywords again, if and then. And with that, we can say that this part of the statement is P, and the second part of the statement is Q. So that's our statement symbol. If P, then Q. If a polygon is a quadrilateral, then it has 4 sides. So now we need to make that into a converse. And if we turn that into a converse, we need to negate both of the hypothesis and the conclusion. So we need to negate P, and we need to negate Q. Now, we will have to turn this converse symbol into the converse statement. And that basically states that if a polygon is not a quadrilateral, then it does not It does not have four sides. So I hope you can see from there, our P, if not P, then not Q. And now we will be turning over the page and work on example B. Here we have our statement, which says if two angles are complementary, then their angle measures add to 90. So we have here if P, then we can write down though. If P, then Q. There's our conditional statement, and we will be turning that into the converse. And remember, we'll just have if not P, then not Q. And if we take the statement for this, you will say if two angles are not complementary, then their angle measures does not add to 90.